Hello, good morning. Hello. Good morning, how are you?
Fine. Good morning, West.
Abdallah, I know that you are always the first person to join. That's a very good one. Ahmed Laban, how are you? Good morning. That's a good one. Turkey, good morning, how are you?
Miss, I'll go a little bit and I'll come.
Okay, I'm going to start now. Okay.
Hi, Miss.
Good morning, Turkey, how are you?
Fine.
Okay, I'm happy that you are here now. So we are going to start because of our time. Can you see my screen?
Yes.
Okay, I'm going to do something now. Okay, so you know the last time we met, we talked about the ocean current. So today, we are going to start with the lesson 2, and that is exploration 2A, modeling the deep current. Now, before we go on, I will show you the objective for today's lesson. And the objective is to use models to represent energy and matter flow within systems and to describe phenomena that relate to deep ocean currents. Actually, I'm going to show you a demonstration through the video how the two major currents that we have in the ocean, they interact. We have the cold current and we have the warm current. And we are going to do this demonstration with the cold water and the warm water, which I would like all of you also to practice at home. And when you do that, you can make a short video on that and send it to me. That would be interesting for you and just a diversion. So that's the objective of our today's lesson. But before we go on, I want to quickly review with you what do we mean by ocean current. The ocean current is the general movement of a mass of oceanic water in a definite direction. You know, when we are talking about the ocean water is always moving, but when the current moves in form of streams, you know, flowing, you know, like the stream that is flowing on the land, you know, they are not so large. So also we have on the ocean water, we have current that is always flowing like a stream on the surface of the earth. Then ocean currents are the most powerful of all the dynamics of oceanic waters because these drive oceanic waters for thousands of kilometers. So the ocean current that we are talking about can go thousands of kilometers. Even from one country to country, we have currents that go, the currents that can move from Qatar here to London to US, they can move thousands of kilometers. So they can move very, very fast. Then if you look at this, can you see this picture? Examples of oceanic water oceanic currents that we have. The red is showing the warm current and the blue is showing the cold current. And you know, we talked about this one, the deflection last lesson, because of the shape of the land. So that's why it's changing the direction. Instead of it to be moving straight, it's moving, you know, changing north, south, west, and east. So that's the review of what we have done in the past. So we are going to look at, if you look at this picture, you can see that they have the same. Now I'm going to ask you, who can tell me what is this red showing? Yes, this red cup is showing which type of water?
Hot water.
Very good. And the blue one is showing which one?
Cold.
Cold one.
Cold water. Very good. So in science, we always use the blue to represent the water, but cold water, and in this one, we are representing the warm water with the red color. Okay. Now, what we are going to first of all look at is that what is going to happen. You know, when you have in the ocean, you have these two currents together. Something is happening. Can they really move together? Can they really float together? So we are going to look at a small experiment on what happens when this cold current, the hot water, I mean the warm current and the cold current, when they interact. So we are going to see what happens, and I also want you also to try the same thing at home, but please make sure that your big sister or your big brother is with you when you are doing it. You are not going to use the hot water, but very warm one, lukewarm. Okay, so let's say so I'm going to quickly share something about this, what is going to happen. Let me show you the video on that. But if you have any question, can you ask me now concerning that? Who can tell me what is going to happen when the cold water and the warm water, when they come together? Yes, who can tell me?
They will
mix. Okay, it's like one will go up. Which one do you think that will go up, and which one will go down?
Both.
Both will go up. Okay.
No, both will go. No.
Yes. Which one is it? The cold that will go up or the warm that will go up? Yes, tell me which one. Okay, I'm going to share with you what is going to happen when the hot water and the cold water, when they meet together. Okay.
Miss.
So I want you to watch this. Then after that,
Miss,
now, yes.
my camera is not working.
Your camera is not working?
Yes.
Okay, don't worry, I will explain.
Okay.
Can you see the video? Hello? Can you see the
No,
video?
we can only see.
You can see what?
Your folder. Yeah.
But now, can you see it?
no.
No. Press
Okay.
it, miss.
You cannot see the video now?
No.
What about now? Can you see it?
No.
Tell me, can you see the video? I'm showing you a video.
No, we can't. Cannot see. We are seeing the folder.
Okay. Now let me change this. Let me see. What about now? Can you see the experiment?
No.
Okay, no problem. I will stop this, then we'll continue with what we are doing. Okay. Now, if you look at this one, I'm going to share the folder once again with you. Okay. Now, since the video is not working, but we'll continue with this. Now, I'm going to show you what is going to happen, then we'll discuss about that. Now, this is hot and cold water, okay? And I will quickly tell you something about this hot and cold water, which also you know very well, okay? So what is so important about this one is that hot and cold water are made up of the same kind of particles. You know, both of them, they are water and they are made of the same particles. Is only who can tell me the difference between the hot and cold water? What is the difference between cold and hot water? Yes, who can tell me?
The hot water is hot.
Good, I like that. It's so smart of you. What again? Yes.
Cold water.
Cold water is cold.
Is cold. Very good. So what are we talking about that? When we are talking about coldness and the hotness, what are we talking about in science? We are talking about what? Yes?
The temperature.
Excellent. Temperature. So the difference between the hot water and the cold water is the temperature. Okay? So the temperature of the hot water is higher than that of the cold water. And who can tell me where on earth do you think that we can see the hot water or the cold water? Where? Which continent?
We can see the cold water at Antarctica.
Excellent. Because that place is very, very cold. And also, where do you think that we can see the warm water?
At a jacuzzi.
At where?
Jacuzzi.
Jacuzzi. No, I'm talking, yes, jacuzzi is so good, but I'm talking about on the surface of the earth, on the globe.
The Red Sea.
The Red Sea, okay. So, and where is the Red Sea located? Around where? Around the equator, equatorial area. Very good. That's very good of you. Okay. So, and who can tell me which one is going to have more mass? That is, which one is going to be, be dense? That is more mass, that will be thick.
The hot water.
The hot water. Anybody wants to try again? Okay, let me ask you this question. Water. Which one will move faster? Which one will move faster?
The cold water.
The cold water will move faster? Why?
Because it's cold.
No, miss the warm water.
The warm water?
Because the cold water maybe it have ice, but the hot water it will break everything.
It will break everything. Okay, very good.
And then it make it where going.
Okay, very good. So if you have warm water and the cold water, then you can see that the warm water will move faster because the particles are evenly distributed. They are not compacted together. Okay, so you'll be able to see them, and we are going to look at that. Now let's look at the density. So when we are talking about the density, now hot water have different properties because of what? The differences in their temperature. Density is a measure of the amount of mass in a given volume of substance. So with this, we are able to look at what is going to happen, the properties of both warm and cold currents. Now, what do you think will happen when cold water and warm water are put in a contact with each other? Which one above the other?
The cold will be down and the hot will be up.
Wow, that's a good one. You finished the experiment already. So the warm water will be up and the cold water will be down. Okay, what about if you put the cold water on top of the warm water?
It will mix.
It will mix. Oh, let's see if this is correct.
I saw the video.
Okay.
Me too, I saw the video.
Okay, you saw the video because I'm reviewing what. Okay, that's good. So that was the video I wanted to show you also. It shows that you are really studying. Keep it up. Now, let's quickly look at the properties of the cold water. Number one is very slow. you know, slow moving. It doesn't move very fast like that of the hot water. And it has, you know, something that is moving slowly. It's like when you are doing your exercise. If you are moving faster, what will happen to you? You'll be sweating, you know, and you have more energy after your exercise, okay? Because the more you move, the more energy. You need energy to move faster. You know that? It's like when you want to run,
Yes.
you need more energy. And when you are walking slowly, that means that your energy is very small. So the same thing with the cold water. Cold water moves slowly because of what? It has less energy and it's more dense. It's like when somebody is big, you know, you cannot compare somebody that is very big to run with a 5 years old boy that is very, very fast. So, and also the hot water, it has more energy, it's less dense, and the particles inside the hot water, they move very, very fast. So now, this one, we go and to do it orally. Who can tell me from the experiment, what is your observation when the cold water is above the warm water? Yes. When you have the cold water above the warm water, what do you observe?
The cold water will not, it will mix
The cold water will mix with it.
with the warm because the cold water is up.
The cold water is up. Okay.
It will mix. But
That's good.
if the warm water is up and the cold water is down, they will not mix.
Okay. But who wants to give me other explanation again? Okay, now let's look at some pictures. I'm going to show you some pictures to explain this, what happened here. Now, this is the first thing. Can you see these two students? Okay, they want to do the experiment. The first one is showing which one? Which water is this one?
Water, the
Hot.
Hot water, warm water. And this blue one is what?
The
Cold water.
Cold water, very good. So let's see what happened, because I want you to try this experiment also, and I want you to send the video to me, not more than 5 minutes, okay? So now, what they are doing now is they exchanged. Can you see the two of them, they exchanged? They want to see what is going to happen. So you now have warm water here and the cold water, okay? Also, they have the same thing. So they get something like a paper, a cardboard, just to, you see that the first student is placing the what? The cold water over the warm water, and the second student is placing the warm water over the cold water. So they want to see what is going to happen. Let's look at it. So you have to remove this cardboard so that the water can mix together, okay? So see the next picture. Can you see what is happening? Who can tell me what is happening in this picture?
The water is getting to mix. They are mixing.
You know, this cold water above the warm water is what?
Yeah.
It's like it's mixing. What about the warm water over the cold water?
No, because the one
They're not mixing.
Water up.
Why?
Because the hot water is up.
The hot water is up, and why?
And
who can tell me the reason why?
And the hot water have a lot of pressure.
The hot water has a lot of pressure.
More pressure.
If it has, it should be able to go down, because pressure press things down. We get the name pressure from press. So when you have more pressing down, then it should go down. Okay? So it's not, I don't think it's about the pressure. If we want to talk about the pressure, maybe it has less, okay? Less pressure than the cold water.
Less dense.
Yes, less dense. That's the vocabulary I've been looking for. That's a good one. Less dense. And that means the cold water is more dense than the what? The warm water.
Water.
Yeah. Can you see the final result? Where's Bada? Bada is not talking. Can I see your face, please? Show your
Miss,
video.
my camera is not working.
That's
I can't
Abdallah.
fix it.
Okay.
I'm here.
I can see you. Your camera is not working. What about Bada?
Not working.
Okay. Bada, can you show your video?
Miss,
Very
I can't. I'm pressing start video. It's not working. It's writing. Make sure that your camera is powered on and is connected to your computer.
Okay. Bada, can you hear us?
Yes.
Okay. Now, do you understand the experiment?
Yes.
Yes. Everybody, do you understand the experiment now?
Yes.
Okay. So that's what happens, and that's why the warm water can move faster. Can move faster than the cold water. Okay. So we go to the last one, and I forgot the person that told us less dense, and that will take us to the next one. We are going to talk about density. I remember that.
Miss, can you show us the video?
Yes, I will show you. I'm trying to see if I can show you the video now. Okay. So, but before that, who can tell me how you can go about this experiment? Are you ready to do that?
Yeah.
The experiment? I really want you to do the experiment and show me the video of the experiment. It might not be more than, more than 5 minutes. Can you see the video now?
No.
What do you see on your screen?
Yeah.
Yes, can you see what's happened now? This
Yeah. Yes.
warm water is not changing. It's not mixing with the what? With the cold water.
Hot
Who
water.
can tell me why? Why? It's not mixing because the warm water is less dense than the cold water. Okay, so let's continue. Okay, we now come back to, can I see your videos? Can I see all your faces?
Yeah.
Okay, very, very good. Now we now come back to I will quickly introduce you to density. Now that we know what will happen with warm and cold currents and how the reason why they move faster than the other. Okay, so we'll come back to the class now, and I'm going to talk to you about the density. Okay, now density is the measure of amount of mass in given volume of substance. And we measure it, that is when you are comparing the amount of mass in a particular liquid. It's like when you put 1 cup, when you want to make your tea, and you put 1 spoon of sugar, okay, compared to 1 cup of tea with 10 spoons of sugar. Which one has more density of sugar?
The 10
spoons. Okay, so that's why the density is about the comparison You know, when you are talking about the amount of mass in a given volume of substance, and it can be measured in kilograms per meter cube. Now, can you tell me which one has more density, fresh water or salt water?
Salt water.
Salt water. Yes, very good. Why did you conclude like that, that the salt water has more density? Yes. Abdallah? Yes, tell me why. Why does the salt water has more density than fresh water? Yes, we want to try. Ahmed Laban, you want to try?
Miss,
Yes.
is it because this the salt water has salt?
Yes, that's just it, because it has more salt, too much salt. You know, anytime you go to the sea line, if you taste the water has too much salt in it, okay? And all this one they add to the density, it makes it more dense. How many of you have been to the Dead Sea before?
Me.
Dead Sea. You know, people float there very well, you know? Do you think there's any fish in that Dead Sea? No fish,
Yes.
because too small. No, because no life can survive there. It has too much salt. You cannot compare
Yeah,
the water here
if
at our
anyone
sea
stays
line.
in the water, they will float.
They will float because of too much salt. That means it has more density. Okay, so that's what we are talking about, the density, okay? Now, if you put a metal into water, what will happen to the metal? The metal. When you put a metal into the,
It will sink.
it will sink. Why?
Because the metal have a lot of pressure and it's so big.
Yeah, that's why the density comes. That's a good one, Turkey. It has a lot of density, more mass than the Turkey. What is this? Let's continue. Okay, so in gases and liquid, matter is, I'm just checking something, okay? So in gases and liquid, matter that is more dense than the matter that surrounds it will sink towards the Earth's center. Okay, I will quickly share you something and you'll be able to tell me more about this. Can you see the video?
Yes. Miss, is it egg?
No, golf ball.
Oh.
Alhamdulillah.
Can you see that's the fresh water? And this is the salt water. Can you see what it's doing there? Okay, you know, they have the same temperature, not cold water or warm water. But now we have the fresh water and the salt water. To differentiate, you now put coloring. You can try it at home also. Please, I really need to see your videos. I'll be so happy about your experiment.
Miss, I don't have food coloring.
Me too.
No, it's always in the kitchen. Ask your mom. It's always there, okay? So even the food color, the one that you use for your color, something to differentiate, okay? So now if you put it, you will see that the fresh water, can you see that the fresh water is not going down? Who can tell me why? Because
Because the salt amount of pressure and does not want it to come down.
Yeah, because it's less dense, it's lighter.
Yeah.
It's lighter, it has less mass compared to the salt water. Let's continue.
Miss?
Can you see that the golf ball passes through the fresh water, but when it gets to the salt water, it floats? Yeah,
Miss?
because, yes, tell me.
It's laggy.
Yeah.
Okay, now let me play it again.
Miss, send it to us.
Okay, I will send it. Okay.
Yeah, can you put it in the model?
Yes, I will
Yeah,
put
because
it.
we cannot see so laggy.
Okay. Okay, I will put it on the Edmodo for you so that you can watch it again and make your comment concerning that. Okay, so that's about this is just to show you the relationship between the density and the salinity. Now, the differences in water, why water sometimes move relative to energy. And when we are talking about the salty water, we are talking about the salinity. And salinity is a measure of the amount of salt in water. It depends on the amount of salt. What makes the density to be different is because there's too much salt in the water. So I will post this one into the Edmodo for you to check again so that you'll be able to learn more about the salinity. And even from the video we watch, you can see that this water, different things and different particles, they float in water. Some will sink and some will float, depending on the density. So, and the salinity of the ocean, when we are talking about the salinity of the ocean, it depends on this one, the precipitation, evaporation, addition of fresh water, and the formation of ice in the ocean water. What happens when the rain falls? Fresh water will come in, and when you have more water on the ocean, the salinity will become less. And evaporation will make the salinity to become more because water is removed from the ocean. When you remove water for something, then you have more of, from the salt water, you have more salt. But when you add more water, you add what? More. Now, I want to ask you a question. If you prepare a cup of tea and it has too much sugar, what do you do?
I put more tea.
You put what?
More tea.
See, but it will make it more sweeter too. Maybe you want to reduce the sweetness. What do you do?
I put salt.
Ah, no. Yes, tell me, what do you put?
Hot water.
Hot water, you put more water. That's good. You put more hot water, and that's representing our precipitation. When you put more water, when there's so much rain on the ocean, the salt will become reduced. Okay? But when you have too much, when there's evaporation, you remove water, then you have more salt. Okay? So all these things, evaporation, precipitation, they affect the salinity of the ocean. So both temperature and salinity affect the density of the ocean water. So I'll already send this PPT, but I will send all the videos to you so that you can learn more about these two vocabulary, the two concepts, the salinity and the density. So this will be the summary of all the things that we did today. We talk about the warm water, the warm current and the cold current, the density and the salinity. Okay, so the temperature of ocean water varies as well. When you move from one part of the ocean to another, they have different temperature. Like Turkey told us at the beginning of the class that we have cold currents more in the polar regions, like the Arctic region and Antarctica. Okay, near the equator, we have the temperature where you have the warm water and the warm ocean current, and the temperature is about 30 degrees centigrade. And at the polar region, the temperature is about minus 1.9 degrees centigrade. So this one will take us that one measurement of salinity is the number of grams of salt dissolved in 1 liter of water. Salt. Okay, so we get the salinity from salt. Okay, the amount of salt. Any question before we end the class?
Yeah, Miss, we have homework today.
What I'm going to do today is that, I sent this PPT yesterday. So I'm doing this one to explain more better, and I'll post this one again with the videos, okay, so that you can go through it, then you'll be able to do your assignment. I'm going to give you assignments based on this. Is very,
Okay,
very
Miss.
okay.
Miss.
Yes.
Miss. Right, we have exams.
Your exam, yes, but
What are
if you are going to have your exam, don't worry, I will take my time to review with you on Zoom
Miss,
online and revision
what
paper.
what are the lessons we're gonna take? Which books?
I will let you know. But let me tell you, it's going to be very, very easy. I will take my time to review with you online on Zoom, and also revision papers will be sent to you also. Okay?
Okay.
So any other question again? Do you understand everything?